in a lot of my classes, I teach math and technology actually. We do the bridge build in both my technology classes as well as my math classes for an engineering challenge. And this past year I've been moved out of my portable doing more technology, and they need the space for other teachers. So I usually leave a whole bunch of these bridges inside the portable, and then we have them there to look at all the time. But due to space and other people using the portable, they were going to throw all these out. So I figured I would grab my video camera and get a quick video of some of these bridges that I had laying around the classroom. That is a crackling fire. So that we could see these and people can take some ideas from these. This one is my bridge that I built a while ago. It is a little bit rocky now, I think. So from time to time, students take some of these bridges and instead of planning out how they want to build their bridge themselves, they take one of these bridges, which is another kind of good reason that I have to go through these now. They take these bridges and they just try and copy this type of bridge. While that's happening, this bridge I think has been dropped a couple times. If you look at how this bridge is held together, and I'm going to show you some examples where this isn't the case, but it's only held together by 4 little popsicle sticks. That's it. Because in this challenge, it's key to try and keep your weight, the weight of the bridge down. This bridge has held all 20 of the textbooks for, I've been doing it for about 4 years now. The first couple, during the first year, I did not get on video, but since then I've been getting more and more on video. This is what I mean about one being very similar, almost as if they had this in front of theirs. This is another student's bridge. Same type of butt joints, same type of inside these triangles on mine. The middle piece goes up into the middle of this cross beam. And then I have 2 outside ones to support it on the outsides of those cross beams. This one has the exact same thing. Almost the exact same size, almost as if they had this one right in front as they were building this one. This bridge also was able to hold all 20 books and was a fantastic bridge. This one's not even rocky at all. Definitely held all 20 books. And again, only has one, I'll put it this way, has 1, 2, 3, 4 popsicle sticks holding that together. Great bridge right here. If you build a W-style bridge, you can win lots of money. It's almost like close to a $2,000 scholarship to Mohawk College. But not everyone is necessarily going to Mohawk College. So if you build a truss bridge, which does not have support on the sides, pushing against these 2 blocks on the sides here, if it does not have that, that's called a true truss, and then you can win a cash prize. So sometimes people go for that cash prize. Okay, now, as I was talking about with my bridge along the top, you don't have to build something solid that a car would drive across. This is kind of like the structure of the bridge. They would put something light across the top so that cars could drive on it. We're just building the support structure. So, some students start building something like this by putting a whole bunch together. And what they find out quickly is that this gets really heavy really fast. With all that glue, all those popsicle sticks, there's a weight requirement. Your bridge can only weigh 250 grams. So what you need to do is make sure that you're not doing something like this, and I'll show a couple where the bridge weighed too much. Some of them even held all 20 books, but weighed too much. So people start with these and then end up throwing them out. Ooh, the glue in this really burns nice. Throwing them out. They make good coasters. They also make good firewood. Here was perfectly good bridge, held all 20 books, was constructed pretty good, has quite a few, let me just remove the name here, has quite a few pieces going across, but that isn't the really heaviest part of it, is each one of these triangles on the side is about 5 popsicle sticks thick. So all these parts are 5 popsicle stick thick, with lots of support at the top, lots of support at the bottom. This bridge held all 20 books, but was a little bit too long. Went too low. You'll get a copy of all the parameters and design specifications. A little bit too low, as well as way too heavy. So it's better to be within the parameters and not hold all 20 books than to not meet some of the parameters. Here's another one. It was pretty heavy. I believe this one held all 20 books. I'll see if I can find the video of it. But it's got a cut right down the middle. So if this was a year that we would be sending it to the Popsicle Stick Challenge, I feel like that's where it's going to break. This middle is going to give, and that's going to give out. As well as, it can only be, at the side here, 2 popsicle sticks high. When we measured this one is too tall. So it would be immediately disqualified from the competition if this were a year that it was going to Mohawk College to be in the competition. This one, again, very heavy. Not over the limit, but very heavy. Lots of popsicle sticks on the top, lots of popsicle sticks on the bottom. One problem with this one is when you're designing a bridge, these supports, these arcs that come up the side here, should not go right to your top. Because what ends up happening is it doesn't sit well. This had another piece that kind of went across here. They were trying to build up here, and that just popped off. And that's where it fell into the middle here. So you gotta watch something like that. Continuing on, this is half of a bridge. It had some issues. They realized that they had put too many popsicle sticks throughout the top. So what they ended up doing was taking it to a drill press and drilling out some holes so that it didn't go over the weight requirement. This one actually was fine for weight, but some of this, because they didn't plan for that, wrecked some of the structural integrity, and it did not hold too many books at all because one of the sides ended up just popping off because it wasn't fully supported across the bottom here. So plan for that weight so you're not having to compensate for it later. I think there's names on here that I don't want to show. So they just build a flat style bridge like this. This one in the video, I think this was the closest one to holding all 20 books. I haven't had one that's held all 20 books. I think this one, it does have some, there's names on the bottom, but it does have some triangles along the bottom that are flat triangles that hold this whole bed of popsicle sticks together. It's within the weight, it's within the height. In the video, I'm putting the books on and then I kind of stopped to look underneath it because I'm surprised that it's holding so much. And then as I go to get the next book, it ended up breaking. So maybe if I had done it quicker, it might have held all 20 books. I believe this one got to about 18 books, which is the highest I've gotten for a flatbed bridge. Normally we want some type of truss support. Now, there have been other flatbed bridges that have been entered, one such as this, but what happens is they're due to poor planning. This was supposed to be, make sure there's no name on there, this was supposed to be a side of a bridge. Remember, we get 2 weeks to work on this. This is what was built by the end of 2 weeks. So what they had to do is they had to put this together and just build a flatbed bridge out of one of their sides because they didn't have time to build another side. This takes, because we have to use the glue that's provided in the kit, this takes a little bit longer than we might think. So time management is a very important thing for this project. Another thing that sometimes people do is if they only have one side, is they end up making a single truss and they end up making that one side really thick. Sometimes that works, but if your side isn't very strong or is wobbly, it's not going to be able to support those bridges very well. And like in the Mohawk College thing, if we got to chase your bridge down the river, that is failure. They call that failure. It's still getting warm. Okay, I'm going to try and zoom through a couple of these. More planning. This is why we draw our plan and build towards what we've drawn, because they just started building, not even realizing that this would not fit within the support. Okay, make sure we know what we're building. We may know all the design specifications, but if we're not building towards them, there's no way we're going to be successful. Here's another example of that. No one-to-one plan, so they had a hard time making it work. This bridge here held a lot. As you can see, it has these side supports here that are pushing against the sides of the support pieces. So this type of bridge is not a true truss. This type of bridge would be going to try and win the competition. The simulated arches that typically win don't have this much structure to them. This is fine for our class. This will hold all 20 books a lot of the time, as long as it's within all the specifications, which this one is. And it is not held together. This one again, 1, 2, 3, 4, 5, 2 at the bottom, 6, 7 pieces across to hold this together. So the weight on this was pretty low, and that's how it was able to be successful in our school challenge. And I'm not sure how successful it would be at Mohawk, but it held all 20 books, held 50 times its weight, met all the design specifications. Excellent. Also, it's pretty aesthetically pleasing too. This one looks nice. This is one of my favorite ones aesthetically. It didn't come out perfect, but it is a truss bridge. It doesn't rely on the sides for support, but it's got some really cool supports in here. Lots of triangles, this kind of neat diamond in the middle, is a very cool one. This one also held all 20 books. Lots of butt joints on this one. So this person actually cut all the pieces to make the meat. Oh, I'm like cooking here. This one did not use too many cuts. They did use some cuts, not too many. So we were saying, a question that usually comes up is, can you make a bridge without having to cut all the time that can hold all 20 books? Definitely yes. I really like this one. This is one of few bridges. We were saying how a triangle makes your bridge stronger. One of few bridges that uses on the inside triangles going diagonal that way, which is something different. This is the only bridge that I've seen that's done something like that. This one definitely was able to hold all 20 books. This one also, those triangles come right up into those cross supports, which is very cool. This one, many cuts, lots of butt joints. If I can move it right up close, you can see all the different cuts to make this super close. Held 20 times its weight. This was a really good bridge. This one here, this one, good idea. It was too heavy though. It held all 20 books because these end up pushing on the outside. But look at all that glue. This one's just gonna go up too. I'm gonna hang on to this while I show the last one. Another good one here. Super triangles, triangles inside of triangles, inside of triangles. I believe this one also held all 20 books. No cuts. There you have it. I hope you enjoyed watching all these great bridges, and I hope that helps for you building your bridge. Seeing some of these past great and not so great bridges, some of the problems you might have that you want to avoid, some of the good things that you might want to incorporate into your bridge. Hopefully. Good luck building your bridges. Oh my gosh, I'm burning. I'm dying.